Hey everyone! Welcome to Study Clips Library's yet another interesting video. Imagine trying to build a treehouse without measuring the wood first. It'd be a disaster, right? Physics is kind of like that. We need measurements to understand how the universe works. Measurements tell us how much of something there is. But numbers by themselves aren't enough. Imagine asking for 10 of flour for a cake recipe. 10 what? Cups? Tablespoons? That's where units come in. They give meaning to our measurements. They tell us what we're measuring and how much of it we have. Without units, we'd have a bunch of confusing numbers. Units help scientists everywhere understand each other's work. It's like a universal language for science. Get ready, because we're about to explore physical quantities. These are the building blocks of our physical world. These quantities describe the characteristics of things in the universe. From the vastness of space to the smallest particles, everything can be measured. Now these quantities come in two types, scalars and vectors. Each type has its own unique properties and applications. Scalars are easygoing. They only care about magnitude, how much of something. They are straightforward and simple to understand. Think about temperature, mass, or time. These are all scalar quantities. 25 degrees Celsius tells you how hot it is, giving you a clear idea of the temperature. 50 kilograms tells you how heavy something is, providing a measure of mass. And 30 seconds tells you how much time has passed. No need for direction. Scalars are all about the how much. Vectors are a bit more particular. They care about both magnitude and direction. Imagine driving a car. It's not just about speed. Speed tells you how fast you're going, but velocity tells you how fast and in what direction. That's a vector. Forces are also vectors, and they play a crucial role in physics. Pushing a box with 10 newtons of force to the right is different from pushing it with 10 newtons of force to the left. Direction matters. This is why vectors are so important. Understanding vectors helps us understand motion, forces, and lots of other physics concepts. They are essential for comprehending the dynamics of the physical world. Imagine a world where every country had its own measurement system. Every time you traveled, you'd have to learn a whole new set of measurements. Buying groceries, measuring distances, or even cooking would become a nightmare. That would be super confusing. Thankfully, we have a solution. That's why we have the International System of Units, or SI units. This system was established to create a universal standard for measurements. They're like the universal language of science, allowing scientists from all over the world to communicate their findings clearly and accurately. We have 7 fundamental SI units, each serving a unique purpose in the world of measurements. Meter for length, how long or short something is. It's the basic unit for measuring distance. Kilogram for mass, how much matter something has. This unit helps us understand weight and mass. Second for time, how long something lasts. Time is crucial in every aspect of life, from cooking to scientific experiments. Ampere for electric current, how much electricity is flowing. This unit is essential for understanding electrical circuits. Kelvin for temperature, how hot or cold something is. It's used in scientific research to measure extreme temperatures. Mole for amount of substance, how many atoms or molecules are in something. This unit is vital in chemistry and physics. Candela for luminous intensity, how bright a light is. It helps us measure the brightness of light sources. These fundamental units are awesome, and they can be combined to create derived units. Derived units are combinations of the fundamental units to measure more complex quantities. For example, speed is measured in meters per second, which tells us how far something travels in a certain amount of time. This is just one of the many ways SI units help us understand and navigate the world around us. Let's dive into some fascinating physics experiments. First, up density. Density tells us how much mass is packed into a certain volume. It's a fundamental concept that helps us understand why some objects float while others sink. Think about a bowling ball and a beach ball. Both might look similar in size, but there's a big difference in how they feel when you pick them up. They might be the same size, volume, but the bowling ball is much heavier, mass. This difference is due to the materials they are made of. That's because it has a higher density. Dense materials have more mass packed into the same volume. To measure density, we need to know the object's mass and volume. We can use tools like a balance scale for mass and water displacement for volume. We can then use the formula density equals mass divided by volume. This simple equation helps us calculate density easily. Next, let's talk about pendulums. These simple devices have been used for centuries to study motion and time. A simple pendulum is just a weight hanging from a fixed point that swings back and forth. It might look simple, but it reveals a lot about the laws of physics. But it can teach us a lot about gravity and motion. The regular motion of a pendulum is influenced by gravity, making it a perfect tool for timekeeping. The time it takes for a pendulum to complete one full swing is called its period. This period is consistent and can be measured accurately. The period depends on the length of the pendulum, not how heavy the weight is. This means that even if you change the weight, the period remains the same. A longer pendulum has a longer period. This relationship between length and period is a key principle in pendulum motion. This simple idea has been used to make clocks and even study the Earth's gravity. Pendulums have played a crucial role in scientific discoveries and timekeeping. Hope you enjoyed watching this video. For more educational videos, subscribe to studyclipslibrary.com.